We're in section 1.5, and we're talking about special angle pairs. Now, I know these lessons where we're talking about a lot of terms, where we have all this different vocabulary. So I know it's not really exciting, but what the vocabulary that we're using today, just to reemphasize, let's stop talking, guys. We're going to be using this vocabulary until we'll be using the same vocabulary in May. So it's really important. So that's why we spend so much time on it at the very beginning. So our special angle pairs. We're going to talk about several kinds. First is adjacent angles. What does adjacent mean? Next to. They're next to each other. And one thing that we like to do in math is be as precise as we can. So we're going to say that they have a common side. They have the same vertex. And they don't overlap. So in a set of adjacent angles, if we were to draw them, it looks like the drawing we did for our opener. So angle 1 and angle 2 are adjacent. They share a side. They have a common vertex, and they don't overlap. So that means one doesn't go inside the other. They touch right here, there at that rate. And we could also have adjacent angles that look like this, and we will give this kind of adjacent angle a special name. So those are our adjacent angles. We're good there? Okay? Vertical angles. Vertical angles have there are two angles. With opposite rays as sides. And if we put two opposite rays together, what do they make? A line. So we can think of this as two crossing lines. And the other way that helps us visualize it is they make an X. So vertical angles, there are my two crossing lines. And the reason we call them vertical angles is we usually think about angle 1 and angle 2. And they're vertical, they're across the X from each other. But we could also call angle 3 and angle 4 vertical angles, because they're across this X from each other. The important thing about vertical angles is the X has to be made by lines, by straight lines. So 1 and 2 are vertical angles, 3 and 4 are vertical angles. Are we good there? Did we talk about adjacent angles, vertical angles? We'll be talking about all of these things in May, like I said. All right, next special pair are complementary angles. Anyone know what complementary means? Very nice. Doesn't mean they're saying nice things about each other. So two angles whose measures add up to 90. And the way we draw complementary angles, a couple different ways. So we can divide a 90-degree angle into pieces. So I'm going to say this angle is a 90-degree angle. A little square tells us it's a 90-degree angle. And then I'm going to call this angle 1 and angle 2. So those two would be complementary because they add up to 90. Well, they don't have to be next, the angles don't necessarily have to be adjacent to be complementary. They just have to, the measures just have to add up to 108 or to 90. So I could have a 23-degree angle and a 67-degree angle. So these are complementary because 23 plus 67 is 90. And as we work through this, we're getting into the place in the book where we have to remember, don't go by what the picture looks like, go by what the information tells you. So unless this is marked as 90 degrees, you can't assume it's 90 degrees. Just because they look like they're a certain measure doesn't mean they are. Sometimes they draw the pictures on purpose to look one way to try to trick you. All right, so there are complementary angles. Supplementary. So if complementary angles add to 90, what do you think supplementary angles add to 180? So their measures add to 180. And I want to go back here really quick. We call these angles complements of each other. So 23 degrees is the complement of 67 degrees. Angle 2 is the complement of angle 1, is how we say that. So picture for supplementary angle. Pair. We already drew one. Look like that. Angle 1 and angle 2 are supplementary. And they don't necessarily have to be adjacent. So we could have something like this. And something like that. And I know my drawings aren't perfect, but that's okay. And this could be 57 degrees, for example, and this could be 120 degrees. And these two would be supplementary because 57 and 123 is related. And we say they're supplements of each other. So 57 is the supplement of 123. Angle 1 is the supplement of angle 2. Okay, questions so far? Just naming these things. It's the complementary and supplementary are two that are easy to confuse, and it's really important to keep the two straight. Someone in the last class suggested we have the C and then the backward C to make the S. So complementary is half supplementary. One way to think of it. C is smaller than the S, so the complement is smaller than the supplement. C is first, so it's smaller than S. Different ways to remember how it works. A lot of people come up with different strategies. But you just need some way to keep the two straight. Because you'll get asked problems, if these two angles are supplementary, da 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 da, what do you know about them? And you have to know that supplementary means they add to 180. All right, I want to draw a picture and ask some questions about it. So here is my picture. Oops. This works. This is point A, L, M, N, and O. All right, first question. Angle PAL and angle LAM. Are angle PAL and angle LAM adjacent? PAL, LAM. Yeah? Does everybody agree? Yes, they're adjacent? Common side, common vertex, they share a vertex, same vertex, and they don't overlap. One doesn't go into the other. So that would be a yes. How about angle PAO and angle NAM vertical? So PAO and LAM. NAM and NAM. Okay, NAM, that works too. Are PAL and NAM vertical angles? Couple no's, couple of yeses. The vertical angles, we need an X, right? Well, we kind of have an X shape, but what has to make the X for vertical angles? They have to be opposite lines, and they have to be opposite rays, or what's the other way to say opposite rays? Lines. They have to be straight lines. So PAL and NAM. So we have one straight line, but is this? That's not a straight line, and that's not a straight line. So because they're not made by two crossing straight lines or two opposite rays, that would be a no. Last question about this picture. Angle PAO and angle NAO. Supplementary. Couple of yeses. What made you say yes? These two, 74 plus 106 is 180. So that would be a yes. All right. So this is some of the questions in your homework, kind of like this. Is this true? Is this true? Is this true? About these angles. Make sure you pay attention to what the picture, the information tells you. Don't be tricked by what the picture looks like. All right, a couple more types of angle pairs. A linear pair. What are we going to guess a linear pair is? Two angles that... I'm sorry? What's the key word here? Linear. Linear is made up of the word for line. So two angles that make up a line. Beautiful. So we're going to say two adjacent angles. They have to be next to each other. Two adjacent angles that form a line. And we already drew a picture of a linear pair. There are my two adjacent angles that form a line. And your book, the book also will call this a straight angle. A straight angle and a line, same thing. All right, looking at these. Another example of a linear pair? Another drawing? They just have to make a straight line. Angle 1 and 2, when we put them together, make a straight line. So what do we know about those two angles when we add them together? They equal 180. So what do we call those two angles that add up to 180? Supplementary. So we're going to say linear pairs are supplementary. So linear pairs, if we know that they're a linear pair, we know the two add up to 180 degrees, or we know if they are supplementary. All of those things mean the same thing. Linear pair, supplementary, add up to 180. That tells us we have two angles that are side by side that make up a straight line. All right, so let's look. I want to look at another set of angles, and we'll see what we can figure out about the picture that I draw on this one. So I won't ask you specific questions. We'll just see what we can figure out. All right, so we just want to know what do we know? Yeah.
Angles related to the.
Okay, and what's the way we say that for angles? Congruent. So we're going to say angle 1 congruent to angle 2. Or we could say measure of angle 1 equals the measure of angle 2. Those two mean the same thing. What else do we know? Okay. 3 and 5, yes. Angle 3, angle 5. And who can help them out? 3 and 5 are what do we call them? Vertical.
Angles 4 and 5 are something.
Yes, very nice, because this is a straight line. So angle 4, angle 5, supplementary. And what's another way we could say that? Linear pair, right. And what's a third way we could say that? Measure of angle 4 plus measure of angle 5 equals 180. All of those things tell us the same thing. Anything else we can figure out? How about adjacent angles? Angle 1 and 3 are adjacent. And we have a bunch of adjacent angles here, don't we? Angle 1 and 3, angle 4 and 5, angle 5 and 2, angle 1 and 2. All of those are adjacent angles. And did you have something else, Carolyn? Say the adjacent angles? Okay. So we came up with a lot of stuff here, just from the way this is drawn. So we can figure out a lot of information, given knowing what we have here. All right. Last topic of the day. Very similar to what we talked about with segments. Oh, no, I need to do another example here. So keep this in mind for this next example. This supplementary, this linear pair, this 180-degree thing. So another example here. So this is what we have, and we want to find the measure of angle ABC and the measure of angle CBD. Uh-huh. 19. This is all they give us. So what do we do? What do we know? What do we know about these two angles? What do they form? They're supplementary. They're a linear pair. They add to 180. So what does that tell us to do with these things? Add them together. And that equals 180 degrees. We know how to solve this problem. We've solved the problems like this all week. So combine like terms, 10x plus 10 equals 180. Subtract my 10, 10x equals 170. Divide by 10, x equals 17. And then I'm going to substitute into these two to find my angles. So the measure of angle ABC equals 3 times, guys, let's stop talking, please. 3 times 17 plus 19. When I calculate that out, 3 times 17 plus 19. I get 70. And then when I calculate out, so what could I do from here to find the other one? Subtract from 180. So the measure of angle CBD should be 110 degrees. And I can check my work and say 7 times 17 minus 9. And I should find that that equals 110 degrees. So because we know that these are a linear pair, they're supplementary, we know we can add the two small pieces up to 180. All right, now we come to our last topic. Are we good with this example?
Yep.
Okay. Angle bisectors. What did we say bisect meant the other day? Cut in half, cut in two. So bisect means cuts in half. So angle bisector is something that cuts an angle in half. So we're going to say it's a ray for now. And we're going to say it divides an angle into two congruent angles. So our picture looks a lot like our opener, except we have to draw it so that the same. These are going to be congruent. and I'm going to call this X, call my vertex here A, Y, and Z for some points on the other rays. And I'm going to say ray AY bisects angle XAZ. That tells us that angle XAY is congruent to angle YAZ. And we call angle, or ray AY is a bisector. So an angle bisector cuts the ray into two, or cuts the angle into two equal pieces. So just like we did with segment bisector, if we had a problem that had to do with an angle bisector, the two pieces have to be equal. The two parts are equal. Questions about bisectors? Okay, quick, easy example here. If that's 42 degrees, and I'm going to call this M, L, J, and N. And the problem says that ray L, M bisects angle J, L, N. So what's the measure of angle N, L, N? Sorry, M, L, N. What's the measure if this bisects J, L, N? What's the measure of this angle? Has to be 42 degrees. Two equal pieces. That's what bisect means. What would be the measure of angle JLN then? 84. Add the two pieces together. So that's an easy example. But angle bisector problems, we add the two pieces and they have to equal the whole thing. Questions? Okay, now we know all about angle pairs, special angle pairs. Homework. There we go. Let's go over the homework.